Three of us today. Today we have a really interesting guest, Aaron. I don't even know. So the funny thing is, this Aaron Glenn, this is the first time we've met him. So literally just from like looking at his Twitter feed, I've been always thought he's a really super interesting guy. So wanted to bring him on. So hey, Aaron, what's up, man?
Thank you. I greatly
Welcome to the
appreciate it.
show.
Yeah, I'm very excited. I've gotten to catch a couple of previous episodes, and I'm very honored. Thank you so much.
Well, of course, there's no honor needed there, man.
Thanks for
So
being
yeah,
on.
tell us a
Yeah,
little bit
exactly.
about yourself. Like, what's your background, and for those that don't know what you're up to currently, let's just maybe let everybody know.
Yeah, sure. So I'm self-employed. I run an independent advisory and consultancy, almost exclusively focused on the service provider niche or segment there. Really, whether it's a vendor, a VAR, or operator, end user, wherever I can help, wherever someone needs more these days, mediation to figure out how to get the problem solved, or maybe some, as most consulting is, saying something that someone already inside said, but being a third party also saying it. That's what I've been doing recently with a deep focus on programmable data planes, the P4 language, which, if anyone follows me on Twitter, knows is about 60 to 70% of it. Previously, I started off in carrier hotels, running patch panels, racking servers, ended up in the network operations center for a tier two type bandwidth provider back when they called them BGP blends, and the 6509 was the king or queen of the rack at those days. And have been kind of, as I like to say, violently independent against my own interests since then. So yeah, that's a little bit about me. Yeah.
Awesome.
Cool.
I love
Interesting.
the blend of you're coming from operations into programmable data paths. So I think there's a lot of us on that painful trajectory as well. So you mentioned your 6509s, man. Were those like MSFC2s, 720s,
Yeah,
MPLS? I think all of
I
it. So you
remember
probably had the
lusting.
early C2 cards that were
All the good
MPLS.
Early,
stuff. Yeah.
early. I remember lusting after the 1 million IPv4 routes. I mean,
Yeah.
honestly, I feel like that's
I
part of
worked
the
on some of
nucleus.
that code. Jeez,
I
way back
got
when.
into programmable data planes because it's like, well, what are these? It felt arbitrary constraints. Slam some more DRAM on it. Why is this a
Yeah.
thing?
Hey,
So now, more than a decade later, I have a lot more appreciation for what's going on underneath the hood.
Yeah, that was interesting
yeah.
at that time. Like going to 1 million routes was not just add more RAM. It was rewrite the algorithm. That's what we were doing. That was some fun math, computer science activity. I was like, oh wow, finally we get to use all of that analysis of algorithm stuff. I learned in school. I mean,
Yeah,
it's
the
so neat.
partial ordering, the ordering algorithms for TCAM updates. I mean, it gets wild.
It's
It
black
gets pretty
magic,
wild.
man. I mean,
Yeah,
and it's really interesting how unappreciated it is. I mean, that and some of the other
really.
crazy features that just made that thing work. Like, you just turn BGP on and let it roll. Um,
Mm-hmm.
with a lot of timer magic, right, and all that. But you know what I mean.
Yeah, but it
That's
scaled
cool.
so well. I had a friend who worked at, I guess it wasn't called UUNet anymore, but 701,
Yeah,
and they had,
MCI,
yeah, MCI WorldCom. I don't think
WorldCom.
it was
They
6500
were one of the first
specifically.
deployments of MPLS.
Three
Yeah,
3,000 BGP sessions, customer
yeah,
BGP sessions, or just 3,000, peering or otherwise on one chassis. That was mind blowing to me that something could scale that high. Not even Juniper was doing that, which was kind of
yeah. No, yeah,
the
yeah. It was
hotness
really
back
weird.
then.
Yeah.
But it's
So for
it's that
those
kind of stuff that
that
I think people want to hear about. That's from your experience. Sorry, Ben.
yeah, so for those that aren't internet dinosaurs, we had back in what
Sorry,
2008-ish.
sorry.
It was like no, I love it. It was like the teenage years for the internet where we were
There
growing
was a
up.
point when we thought we
Like
wouldn't
for
scale
family
this any
outside.
further. Yeah.
How many routes was it? Was it
Right.
600, 700,000? I don't remember.
Oh no, no, back
That's
in my
back then.
day.
It was probably
Back in my day. That was good. I should probably look at Potoroo because it could go either way for me. I want to feel it was definitely under 512. I think it was under 384 back when I started.
Oh yeah, I guess
Yeah.
512
Yeah.
was the
It was
Hundreds of
definitely
predominant.
below
thousands.
512. Yeah, it was a few
Yeah.
hundred. I mean, you you could send an IP justification report. I heard, never done this myself. I heard you could do, you could send an IP justification to Aaron and get a /19, so long as you had some SSL certs or some PTR records. It was a
You
very
used to.
different time. It was a very,
Very
very,
different
very
now.
different
Yeah.
time back then. Oh yeah,
I mean, I
yeah,
ran out of IP addresses when I was at BT one Friday night, and I called Aaron and said, "Hey, I need some," and they were able to figure it out. And
yeah,
not today, man. That's not going to happen.
yeah.
I need another /24. Anybody got one? No, no help.
Look,
You know,
good luck.
But
or
with
even,
BT, we have 15 million customers.
yeah.
I ended
Almost
up
done.
transferring a /22 to Zayo of all people. So even the big ones are out there buying stuff on the open market. Yeah.
Wow.
Nice, nice. What you mentioned one of your projects when you were working on in the service provider space. I thought that was super interesting. Why don't you talk about working to give internet to Africa on that project?
Yeah, I was really lucky to be on the SOM cable project in Eastern Africa on the Horn. In northern Somalia, there's an independent republic called Somaliland. Their capital is Hargeisa. I think at the time it was not quite 2 million inhabitants. I apologize if I got that wrong. But they were served by a chain of wireless point-to-point, what was effectively, I believe, at the time, OC12s, 622 megabits per second, that connected back to Djibouti, where the cable landing station was. The Hermus cable landing station there at the time had 5 cables. I think now it's up to 7 or 8. And the project SOM cable was a private one, private investor, connecting it terrestrially with a 48-strand cable. The cable was indoor rated. I got a lot of stories about this project. This one over a beer is like 3 hours. There's so many good ones. But ultimately, connected it. I didn't quite get to stay there for the entire ring, but the first segment that connected Hargeisa and half of the ring back to make it redundant. Yeah, 10 gigs, DWDM, basic, 100 gigahertz spacing on it. Didn't need it. We turned up a 10 gig port and then turned up 3 more waves just to prove that it was working. But going from
Wow.
622 to 40 gigs, a big difference. And in parallel, they were doing a GPON deployment. We were working on a lot of interesting access type stuff, but my main responsibility was the optical network. Um, had a lot of fun doing that, and it was the greenest of green fields. There was really nothing there but those wireless towers that were getting decommissioned, and yeah, it was really interesting. My favorite part was putting together the team. We got to put together a team. Usually in these projects, I found out later, it's outside contractors. They're out of country. They never really train anyone locally, or those skills
Yeah.
don't get built there, unfortunately. And so I was lucky enough to be able to hire locally, hire engineers locally. 3 of them are still there 8 years later. One of them's the deputy CTO. Love mentioning that.
Cool.
And it's a functional running network. I don't know if they've turned up more wavelengths or upgraded it to 100 gig. I think it should be able to handle it. But yeah, that's definitely the professional highlight as a service provider type person is like,
But
yeah,
it's worth repeating that number at the beginning. 622 meg, for people out there. Think about this. I mean, most people are have a gig or somewhere near, not Brent, but a lot of people now
Stop.
have a gig to their house,
right,
right?
right,
Bidirectional. This was
right,
600 meg for 2 million
correct,
people.
correct. Yeah, or
That's
thereabouts.
shocking. Wow.
What really blew my mind when I first got there was go to the shops to get anything sundries, right? And I got to quickly notice the first week and a half I was there that the shop ladies were watching Turkish soap operas on YouTube, and the game there was you'd start in the morning, get it buffering, Then by the time noon would roll around, you'd have about 30 minutes buffered. So
Have
you're
enough
eating
to
and
watch.
watching. And then the rest of the day, it would buffer the last 30 minutes, 15 minutes, 45-minute hour soap opera. So when you're cleaning up at that, everything's closed down, play the rest of it.
Play the
I
rest.
just
Yeah.
remember going, I remember
Wow.
the days before ADSL, right? So I'm no stranger to difficulties downloading stuff, but it just kind of, that was the first of many, like, oh, wow, this is,
Wow,
this
that's
is
crazy. I mean, there's a famous quote for when I was at BT. One of the guys, I won't mention his name because this is very hilarious. We were debating doing fiber at the time in the UK, and this guy said, "What do we need fiber for? We have DSL, and it's so much faster than dial."
He wasn't
Hmm.
German. Did he
It
go
was
on to
like
work at Deutsche
silent, and
Telekom? I don't know.
it was at BT. Yeah, but it was just silence in the room. We were like, "What?"
They've been squeezing the proverbial blood out of copper here in Germany. Again, I'm here in Berlin at the
Yep.
moment, and very much multiple times people saying, well, we could vector it some more. You don't
Yeah,
need more than
vectoring
200 megabits
works.
per second.
Yeah.
Come on, we'll just vector. If how many more things can we shove through the copper? Yeah.
That's what we'd say. How many more times can we shine the copper up for you? That was the saying.
How polished could it really be? Yeah.
How polished could we make it, right? Yikes.
You just described every telco's rural broadband deployment in the United States as well. So
Yeah.
Currently.
it's a travesty.
Oh my gosh.
So what are trends you're seeing on the service provider side as you're kind of out there in the world that you think are interesting, and like kind of where are you encouraging service providers to go? Are you just segment routing fan? Do you have a bunch of PCEPs running around your house to tell you how to get to the grocery and like, what are you up to
Right.
there?
No, that's interesting. I actually just, I hope to finalize. I won't say it till the ink dries, but I have an engagement around segment routing and PCEP and things like that. Kind of a proof of concept, a pilot. I guess you're not supposed to say proof of concept these days. Whatever. A pilot to kind of verify the tech stack. They're very much on open source. They want to contribute back to open source. They work in markets that are what you would call secondary, not the normal North American, Western European type markets. So they kind of have a different financial model for their SD-WAN and for their overlay type networks. But yeah, no, these days for service providers, everything that I hear from just about everyone can be distilled down to, gee golly willikers, those AWS margins for network services are pretty big. Those look neat. How can I get some of that?
How do I
spend?
get some of that?
And it doesn't even really matter where they are in the value chain or what they do. I feel like I've heard some form of that just from ODMs, from people who make the switches and make the blinking lights. It's like you don't even build a VPC. What are you talking about? Yeah, but those margins.
Yeah, want those margins.
Yeah, exactly. And then on the flip side of it, the eternal struggle for a service provider, whether they're able to do it managerially or not. Sometimes they get distracted with things like, oh, over the top. I'm jealous of over the top. But if for the folks that I see that focus on the infrastructure aspect of it, OpEx, right? Reduce the truck rolls. I don't want to hire any more NetOps people. They chain smoke and they're angry all the time. That kind of thing. And for me, I feel like after kind of being annoying about it, that programmable data planes finally has a good story for that, at least in the service provider space. It's become a lot more mature enough, and folks are out there talking about their experiences. Alibaba Cloud is fully programmable, has been fully programmable. They've been using P4 and Tofinos and other things that are programmable on their forwarding plane to provide all of their services, nearly all of their VPC. Even their fixed function switches are driven via the same control plane, the same type of adaption layer between the data plane and the control plane. So what I'm trying to focus on in between making enough to keep the lights on, so to speak, is examples for people that they can start touching programmable data planes. For a very long time, when someone said, all right, whatever, I believe you enough, or I've had enough
Yeah,
beers.
it was like black magic. Yeah.
But
Nobody had access to.
I'll take the wand and do a little Harry Potter. I'll do a little magician thing and I'll play along. You've annoyed me enough, and then it would be 3 hours of downloading a VM and compiling stuff. And it was just, you can't give me the hello
Yeah.
world immediately. And getting somewhere with hardware was basically impossible. I used to beg, plead, even before Intel bought them. Please, could you just hook up a serial port and like an LTE card? I'll send you the LTE card. I would really just love 90 minutes. NDAs, this, that. Bring them to us. Like, you bored the shit out of them. I'm sorry. You talk to them in slide decks, and then people walk away and go, "Why would I want that?" Recently, at the end of a 30-minute or 45-minute call, even if it wasn't about programmable data planes, I'll have someone. This happened on 3 separate occasions. They go, Intel came in and did the song and dance, and I'm not trying to say anything mean about Intel marketing. It's just that they're a multi-billion-dollar company. They have a different way of going about it. Intel came in and gave us affectionately the song and dance, and I didn't understand it. I didn't understand, why would I need this? What would I do with it? Like, it seems interesting, and sure, yeah, maybe it's bleeding edge, but like, what's in it for me? And they would say, talking to you for like 15 minutes, 30 minutes, like, this is cool. I want to do stuff with this. Now I'm thinking, what could I do with it? And so I've just been trying to focus on spreading the good word with tangible things, with things that you can play around with. And I just did a AppNic webinar with varying success. It's the first one. We got to iterate, get the feedback, things like that. But basically, hey, you wanna build your own layer 2 learning switch? That's it. That's all it is. It sends a frame, possible. It learns the frame. That's it. But just to start somewhere to conceptually get it, because that also includes a control plane aspect, right? You can't make a learning switch without kicking something up and writing
that
something.
We learned from OpenFlow days. Yeah.
That's another thing that I've loved about my journey diving into programmable data planes and just understanding the hardware behind it. Like, I can finally appreciate why OpenFlow left such a terrible taste in everyone's mouth, and why, like, I talk to people and they're like, OpenFlow, I don't want to speak about it again. I recall Nasira making 1.2 billion and Martin Casando making so much money he just became a VC. Like, got a PhD, got the sell. I'm a general partner now. So it was some kind of success, right? But now I get why, especially in the operator space, like, you can't flop
the previous thing was just not tenable. I implemented OpenFlow. I implemented OpenFlow on Junos way back when, and interestingly enough, and it was a thing that was fun in theory, but in practice, there was some stuff missing between, and it had to do with the actual TCAM itself, programming the TCAM and the whole mapping of things onto that, and that's one of the things that in their second go with this they've tried to correct, and that's kind of what the current plan is. And that it's interesting, by the way, I was like, as listening to you talk, one of the things that is also improved these days is the two things. One is the possibility of actually running this thing on real commodity type hardware, right? So programmable NICs, smart NICs, whatever you want to call them this week. That's where the action is heading, and at the same time, the intelligence of the network, everyone's realizing it's better to push that to the edge than to have, 6 huge nodes that are already hard enough to scale as it is, and just kind of pushing it to the edge. And that's the thing I've been working on.
Put the intelligence, the processing, the classification, whatever you want to call it. You got to push that as close to the edge as possible. Slap a label or 2 on it, and then move it wherever it's supposed to go.
And then move it. It's an interesting confluence of sort of requirements of what people want to use, and then what you want to do, and then this hardware evolution, and then maybe P4. We've also talked about BPF and AFXDP is another alternative way to do that. So a lot of people are exploring these 3 kind of avenues these days. Is really interesting.
That's what's really exciting for me, especially you mentioned eBPF. P4 has been the canonical. I don't never know how to pronounce it.
Canonical.
Yeah, there we go. Thank you. See, I can never pronounce it. Anyway,
not Ubuntu.
The P4 compiler uses eBPF as a target for that, and previously, up until very recently, it was kind of basic. It even says that right there in the README. Like, it's mostly a packet filter. You could do some other stuff with it. But recently, Thomas and some other folks from ONF and Orange have very, very recently, 2-3 weeks ago, released a an implementation, a fuller implementation based on eBPF of what they call the portable switch architecture. So in P4, you have a hardware description. So you write your logic, but you also in the same language describe what's going to be running your program. And in this case, for a lot of the software targets, they try to focus on basically a standard, which is the portable switch architecture, and that comes with kind of all the fixins. So whenever you read, maybe if you do, read any kind of research that explores with P4, if you hear about something that supports P4, more than likely it's targeting the portable switch architecture. So now we have eBPF, so in the Linux kernel, accelerated kind of fast, maybe not the absolute fastest. You're not squeezing the most PPSs out there, but it's more than enough to really begin to explore or run a few things in production. And now I can compile all these P4 programs that are written for the portable switch architecture, run them in eBPF, either in userland or in the kernel.
And run them
It
on
really
anywhere.
starts to get exciting. Yeah, it really, because the Tofino, in so many words, also supports the portable switch architecture. So to kind of blue sky, it is quite possible to have the same logic run on software on your Linux kernel and have that almost
That's where I
seamlessly
mean the cool
move
stuff
through
is starting to
hardware.
happen, because you can
Oh, yeah.
finally see like, wow, we can actually build not just toy applications on that NIC. I mean, I can do like the full. I can imagine doing a full thing, or not just imagine. I've seen some of this now.
Yeah, yeah.
It's
To bring
really
back
interesting
Alibaba,
too, because,
they're
like you
doing
said, the
it.
Alibaba example, yeah.
They're doing it with the NICs, with the top of rack switches, with the software underlay, the vSwitch, what have you, and they're coordinating all of them. Like Kubernetes is kind of trying to solve your bin packing problem and scheduling problem. We're going to see the same thing with network functions. I have no idea how AWS does any of their stuff. I was recently quite shocked that most of it is all software. I understand it's DPDK and the transit gateway is heavy DPDK.
Yep.
But I imagine something that looks very similar to other things, schedules these network functions, deploys these things out there, and that I feel like that's going to have a trickle down effect, even if it seems kind of weird now. That eventually, your enterprise telephone closet, when you're deploying firewalls and this and that and endpoint detection, et cetera, all the things that we're trying to shove into enterprise closet switches and now top of rack switches, that edge, right, that we're talking about. If it
The
can't
edge
run on the
part,
NIC,
yeah.
or we don't want to run it on the NIC, then what's on the other end of that jumper, right? Oh, okay, the top of rack switch or the telephone closet or something like that. I think having a way to program these things in kind of a lingua franca, it's not Java, not write once, run anywhere. We learned from that, but some kind of lingua franca that can go from vendor to
It's right
vendor
once
without.
and mostly run. I mean, that's the interesting thing for me, is that like the Linux example, even if you don't have the NIC acceleration, it'll run. And that's the
Mm-hmm.
thing everybody loses
Mm-hmm.
track of. This is I'd get on my VPP FDIO soapbox for
Oh,
a
the
second,
best, the
where
best, the best.
but that their sole goal in life seems to have been like the most high performance thing we could find. At the same time, it's extremely hard to use. And don't discount the fact that what you just described actually allows a more flexible programming model that can be exposed to other people that aren't into like NPU programming at the
Oh
specifically.
yeah,
And
yeah,
it kind
yeah.
of opens it up, and it gets back to the thing I always remind people of. You said this earlier too, like the long tail operational cost of networks is insane, versus the cost of buying the stuff on the first day, right?
Mm-hmm.
And what you're
Mm-hmm.
talking about, it's like, well, I've got basically the systems I have today, and I can do this. I don't need
Mm-hmm.
to spend billions of bucks changing everything again. I can do it, and so it's not the most highest performing thing, but operationally, as we found, like with automation and things like that, that's where the money is, right?
Mm-hmm.
No
Exactly.
truck rolls
Exactly.
to go do my edge config or whatever, right?
Mm-hmm. Mm-hmm.
That's
Exactly.
pretty cool.
Exactly.
Uh,
Yeah.
I think what's nice about this time around, with OpenFlow, obviously, we always had that software-based data path. We had Open vSwitch. So the barrier to entry to doing something useful with OpenFlow was zero, because you can install OVS, crack on, and then like by extension, when vendors catch up and implement in hardware, you could then run the same thing actually in hardware and then benefit
Hmm.
from that. I just feel like with P4, we missed that. You mentioned it yourself. It was like, I can't get the hardware to actually try this. So intellectually sounds great, but like, so what? Now, like we're kind of getting to that point where you said like the developer experience is coming back around. It's like, yes, you can try this out in software. You do not need to invest $1 million in buying hardware for your team to figure out, is
Exactly.
it going to work properly? Like you don't need to
Exactly.
use DPDK because that's the lowest barrier to entry, or FTD or the VPP or whatever.
Whatever.
Like,
Yeah.
Hmm. Hmm.
I think that's what's really exciting now. Like that, I want to go play with that eBPF compiler because that sounds fun.
Yeah, yeah, it's pretty neat. It's not 100% polished, but all the component parts to have fun are definitely there. And that's part of the to what you mentioned, having the hardware, the investment up front and things like that. That was obviously the very first thing I got back when I started talking about
Don't
this.
forget also, even if you can get it today. I just got
Right.
3 servers that I ordered in November.
Yeah, yeah. The chip shortage is brutal out there.
Mhm.
It's things that were about to be written off as tax write-offs. Trident 2 is just flying off the shelf for nearly MSRP because you can't get your hands on anything.
Yeah.
Being able to program stuff like that isn't always you don't need to be Google, and you don't necessarily even need to program your own forwarding plane or anything of that nature in order to realize the benefits of that ecosystem. For me, what I'm trying to kind of get people to understand, and hopefully it makes sense because it's really an idea that I'm kind of grappling with, is that it changes the responsibilities in the client vendor relationship now. If I'm an operator and I have a checklist of things that I absolutely need, and the way that I operate my network, I do need to squeeze the most heat BTUs in that closet per port per packet for stateful stuff. I'd really like to be able to have elasticity in my CG NAT and not necessarily in the central office or the IXP where I'm peering and stuff like that. The one I like to mention is Bell Canada. They wrote their own MPLS implementation that was interoperable in 6 months. And this was 2017, before things got much more polished. There's a whole new version of the language. There's a lot more stuff going on. The
Hmm.
experience is vastly different, but people are able to do that, right? And that to me changes the way that you interact. When I go to someone like Pensando, if I went to Arista they have a Tofino one, if I go to Arista and say, well, hey, I'd prefer to run something either more specific to my needs or more pared down so I can dial in the table memory and the pipeline usage this way and that way because I have this use case that's only one or two things, a la carte, right? A la carte. It changes the responsibilities, right? Now your vendor has to provide you for the chip or for the actual hardware part. They're not providing you an integrated stack, and they're not saying, well, here are the three or two or one in most case software vendor that has bothered to port to our hardware. So that's really the story that you get in disaggregated
Well, it's
networking. Is
always like when you get into that, it's hyper restrictive because the vendor is freaked out that you're going to blow the machine up and then blah blah blah, right? But
Precisely.
yeah,
I was in line with Dr. Mario Baldi, who's a researcher now at Pensando, but he was at Cisco, and he goes, "Well, yeah, Aaron, if I gave the customer access, how do I support it? What, am
right.
I going to have my people debug some random customer's P4 program, and it broke the compiler, and now it doesn't work any way?
Yeah.
I'm
Oh,
going
it's
I'm
simple.
going to
You
give
don't
them
support it. They
P4. What do
wrote
they
it.
know?
Yeah.
Well,
They
yeah,
wrote it. It's their own. But it's
exactly.
that tricky dance, like every vendor I've ever worked for has had this conversation somewhere along the lines of, how much do you let people fiddle with the thing? And frankly, I mean, that's how Arista won, you know, in that whole switch market. They said, you know what, fuck it. We're gonna let people do. We're gonna listen first of all to what the operators want to
That
do. I
was
mean,
that was the
Senator was
difference.
brilliant. I mean, he just said, look, I
That was the
don't
difference.
need 100 features, but this is kind of the flip side of the million features a week that get pumped out of the usuals into the switches. But it's okay, now I've got a stripped down switch. What can I do with it? Right? It's the opposite. And if you
Right.
have a stripped down switch, but like you said, I want to add 3 custom functions for this thing, have fun. you're going to maintain them and all that, or you can hire a third party to maintain them if you want, or whatever, right? I mean,
And that's what I'm kind of hoping for. I've said this since the beginning to anyone who listens to me. Like, I really hope that there's an independent software vendor landscape that gets built. It feels like there's nothing official. No one's ever told me anything officially, but it feels like Intel specifically has begun to start spending some resources on trying to juice, as I like to say, that environment, kind of build catalysts and make it easier for folks to start building that stuff based on these whatever API, one API, P4, et cetera, DPDK, SD, the storage one, IPDK, for IPUs.
So that's where our other co-host is actually the IPDU, IPDK.
Yeah, okay.
We recently started the Open Programmable Infrastructure org, open.
Yeah.
So it's OPI, Open Programmable Infrastructure. I forget the URL, but that's the exact purpose of the organization, is to do what we've been talking about, which is to provide, in an open source context anyway, all of this stuff, right? Programmable environment, the tools, the lab thing to try it out potentially. And Intel has been a really decent steward of that whole thing. I mean, they're front and center involved in that. So they seem to have figured out that that's the way to make this thing successful.
I guess in considering all of this programmable data path stuff, it's kind of, to me, it feels like there's this little renaissance of network ops happening, at least in my brain, because I remember the good old days of building CAT 6500s, and you used to sit there and agonize between, are you going to go buy the SOUP 2 or the SOUP 720? Can you get by on the 2s? Is it going to work, or am I going to have to deploy this and then frickin' upgrade the thing while it's in production?
Literal back of the napkin calculations. Yes.
Exactly. It's like, well, okay, now I still need to have that forward planning, right? And I still need to think about what specifically is it that I need to get my network working optimally. And I can tweak that, and I can go and talk to vendors, and I can actually get the thing that I really, really want. But then there's always that software as well. So I can always tweak something, or I can deploy something, or heck, if they don't support that given protocol in hardware, I know that I can do it in software, and it's going to suck, but I can do it until I can afford to upgrade. And I think that's kind of nice, because a lot of people, I think, coming into this transition from traditional NetOps into programming all thought shit, now I've got to be a programmer, I got to learn how to do all of that. But I feel like those key skills of design are still there, and understanding the knobs and how they ought to be tweaked. I think that's still relevant, and I like that. I like how that transfers.
Well, and I think
it gives operators the flexibility of, they can run it in the slow path, but operators are free to architect their networks how they want. So you can do parallelism.
Yeah.
You just you figure it out, and you can make it work, even though it's running in software, even though I need more hardware components to run it. At least you can run it. I mean, that's also a challenge when you go to a vendor and say, hey, when can you have this new protocol or whatever for me? They come back and say, how about 2 years from now?
Right.
At least you can get it rolling, right?
Dave brings up a good point, though. So I think there's two things that if we've learned over the past 5-6 years on kind of reinventing a programmable network is one, nobody ever got fired for deploying Cisco for the most part, or Juniper or Arista, right? That one throat to choke is huge until integrators with big enough names can actually support some of these crazy ideas that we've come up with. There's just a higher level of risk that an operator or an architect is taking on at times. I think it's getting better. But the other is the complexity of programmable data paths that's inherent, and no matter how many different ways we try and implement it, it's still crazy high levels of complexity, because we are dealing with those low level pieces. Without tooling around it, you're still getting down to the point where you have 20 people in the world that know how to operate how to debug low level of your data path. So there's a lot of risk that you're taking on there as well. We bag on OpenFlow, but Google still uses OpenFlow, and they use it fine. They use it for big links with lots of unique flows. And they can do it because they've got enough people there that can, build tooling around it. So I think that, I always go back to like IP route 2 is one of the most important things to networking because it made Linux networking dead simple. So, we need IP route 2 for actually something I'm going to talk to Dave about pretty soon. So, how do we build tooling up around eBPF, P4, all the different programmable data paths to make a user comfortable in doing it, so that when you do need to do that layer 2 switch demo, it's not here. I'm gonna have to deal with flooding and learning and do all that myself in C.
You just reminded me of something else, Brent, which was like, let's not delude ourselves that, everything was perfect with Cisco. Like, how many of us spent hours on the phone to
Nobody
tag?
got fired, but how much of your hair did you tear out, right?
Oh crap, suddenly I'm not getting routing updates anymore. Why? The BGP processor's hung. Why? Oh shit. Like, that happened.
Soup 720.
It did happen, right?
My old friend Rahman. We meet again.
Right, there you are. The blue screen.
24 hours later, that image is almost done, or it hangs and you restart it. Yeah.
Yeah, I think I had to do the X modem transfer 3 times. I remember them distinctly. So
It's amazing. It really is.
Yeah, I mean, we all ended up doing our own debugging anyway. So, like, I think that, even in the programmable world, at least if there's more eyes on it and the code is available for you to actually look at, if you're that way inclined, like, it's always good.
Well, that was kind of, to the point of tooling, but also inspectability. I come from a generation where you would right click on a website, look at view source, and, you could actually figure out what was going on. You change a couple things, save it, load it up in your browser, and it works. And I don't think there's anything crazy or impossible about doing something functionally user experience similar with networks. And that comes from cracking open, I'd rather it not be this opaque black box, and it doesn't need to be. My argument over, by the time I've drunk my 3rd beer, this is where I'm at. I'm going, hey, just having it codified, just having it in a language that we can like parse and compile. Compilers are magic, right? I can go from one thing to another with a well enough crafted compiler, right? So really the argument is just, well, if you like infrastructure as code, why am I arguing with you about having your data plane, the thing that's literally moving stuff from A to B, the one where you're always like, well, I don't know what's going on. It's the network. I don't know. Did it go through the firewall? Did it go through this switch? Did we SNMP pull at the right time? Did NetFlow sample it? And for a lot of times we're able to fix operational problems with the sampling, with the SNMP. I mean, come on, that stuff's worked for nearly 3 decades now. And if we had to, I'm sure we could make it work for another 20. But do we really have to? I don't think we have to. And I think a lot of the stuff that we're dealing with even today is, as you might expect, deeply informed, deeply done because that's just the way that we've done it, right? Shout out to Grace Hopper, but that's the, Admiral Grace Hopper, that's the dumbest phrase you can say. Well, that's the way we've always done it. Well, great, let's not do it that way anymore.
Yeah, let's think about doing it differently.
When I read the paper for P4 and the idea behind the reconfigurable match action table, like as an abstraction, I'm like, holy crap, yeah. So now, just like my graphics card, again, I played Quake and Counter-Strike on my graphics card. Now it's recommending pants to me. Like, this doesn't, and I've been working with computers for as long as I can remember. And so now we have chips that are just as fast, that are doing it just as quickly, and we can now play with them. We now have an interface to them, and it's no good, right? I can't build an 18-story condo with just sand and mud, right? I need tooling and I need other materials that are around.
You need a plan all that stuff.
Yeah, you need a plan. You need software engineering skills. That's the other thing. Good Lord, you try to tell a service provider.
Well, that's often the totally
engineer
overrated.
Software.
That's the totally underappreciated part of a lot of these things, and a lot of folks. I mean, I'm a coder by training and all that stuff, but a lot of ops folks, sales engineer types, they didn't go to computer science school, so to speak. And so when they get to this point, that's quite a big hurdle to cross, and tooling is one of the things that has helped them, like in the automation area. I mean, we, way back to, Puppet Chef, all of those things. Those things
Hmm.
had
Hmm.
a decent dev environment that you could bring up and do your thing in, some sort of
Hmm.
development
Hmm.
kit thing.
Right.
Um, and that's
Exactly.
really, I can't agree with you more because it's like even for somebody like me who has worked on this stuff in embedded environments, with the baling wire and bubblegum way back when approaches, where you're stepping through microcode, I mean not microcode, but assembly language and things like that. That's just like black magic for a lot of folks. But if you provide a development kit interface that's reasonable, you're going to get more
I
of this.
appreciate hardware people and their black magic. I appreciate it so deeply. Every day I appreciate it even more. And then I appreciate, not that I'm trying to, play favorites here, the compiler
Yeah,
people that
they
make
keep you
that
away from
hardware magic, that keep
that.
you away from all of that.
Yeah,
That's where it starts falling apart. For me, the Broadcom SDK, which is now up on GitHub, talk about a
yeah,
new day. But the
yeah,
Ethernet switching SDK, not only did it have $1 million entry fee, it was intractable, right? You could looked
yes.
on LinkedIn and it was like, I need someone with 20 years experience. You know where the
Oh,
bodies
I've used it.
lie.
I know what you're talking about.
Yeah, yeah,
It was a
exactly, right.
mess.
And so then to go from that to now like, all right, well, look, I'd like to parse these bit fields because these mean these headers, and then if this header means that, then do this,
And that's
right?
it. Yeah,
And
you're
that's
not
it.
writing like a gigantic
And
thing.
going from there now, speaking of tooling, they have higher level languages. P4 is an intermediate representation. You compile down to P4, and then you go to your vendor and go, okay, I got P4 program, right? I
Yep.
wrote it in something else. I mean, these days it's academically driven mostly, so it's written in things like Haskell, you know but to then say you can do something wild like, well, what if I didn't really have a control plane? What if I did all of my routing? What if I did my distance vector? What if I did my telemetry just all in the data plane, like on wire speed? What if I could peel off like 100 gigabits per second on my 12 terabit per second switch and just like recirculate some stuff kind of intelligently, intelligent noise throughout my network? What if I could start doing consensus then? And these sound wild, but they actually work. And they actually replicate a lot of the stuff that operators and service providers are doing today. And I'm not necessarily a fan of large consolidation, right? I'm not interested in Verizon going from 10 million subscribers to 100 million subscribers. I'm not about that, right? But what I would be interested in seeing is being able to scale up both in flows, in customer ports, in the amount of traffic, the packets per second, easier, more easily. I don't need six-figure CGNAT. I don't need six-figure load balancers. I don't need six-figure refrigerator-sized routers that can do 12 stack MPLS labels, or something that to the point tries to play for everyone else. Yeah, it's one neck to choke, but are they paying attention to you, or are they paying attention to a very wide segment of that Gardner quadrant thing? And if you're going after thick margins, and if you're trying to find that niche, or those other niches, you need someone that's really invested in what you need and what you're trying to deploy. And that may not be violently different than someone else that's doing a managed NAT VPC, right? At the end of the day, NAT. That's kind of the argument. All right, well, find your NAT implementation. Now figure out which hardware vendor you like working with, or which software vendor or VAR or NAS vendor that you like working with. Now you can all have a conversation on the functions that you need. The hardware provider provides the hardware that accelerates what you want. The software provider is listening to your needs because all they're doing is building software for you. And it doesn't have to be bespoke per se, right? I envision a day with the right tooling. It's like getting a bespoke suit. Not to be too gendered there, but you walk into Seville Row, you go, well, I like this interior. This feels nice. These are my shoulders. This is my collar. I like it a little looser. I like it a little tighter.
Yeah.
I'm going to this kind of formal event. Now I need something that works for that. You could theoretically do that, and you don't necessarily need a million different options. Everyone's kind of doing the same thing. But to be able to have it to be inspectable, to have someone to actually apply engineering principles and kind of like, I'm a really good network engineer because I read all of the documentation and I know which mailing lists to subscribe to, I know where to ask questions. And that's a skill all of its own, right? That's a skill that every engineer should have. But I look around, my father was a civil engineer. He never quite got the stamp. So officially he was a draftsman, a draftsman, and he did Port of Long Beach, right? the big towers, the piers, the telecommunications, oil and gas fields, stuff like that.
Yeah.
And so I kind of got a taste of what engineering principles were because my dad always wanted the stamp. He never didn't get to university and actually pass the
Got to do
professional
the PE.
engineering.
Yeah.
Right. He never became a professional engineer, but he would tell me all the time, professional engineers would come to him. You know, he was slightly infamous at the Port of Long Beach for his as-builts and his drafting stuff. So when I became interested in infrastructure and eventually ended up in networking and stuff like that, 5 years into it, you know, when people were starting to ascribe me as a senior or something like that, I go, but what engineering principles am I really applying here? Like, a lot of what's going on this line card is a little bit of magic to me, even after reading the release notes, even after reading everything.
Because there's code that's running in there that I don't know about. Yeah.
And,
a lot of
every
code.
time something breaks and I'm sweating and it's 3 in the morning,
You don't
and
know how to
really
fix it.
just go back to my beer. I'm some poor person in Belgium is trying to read hex codes to me, you know, with the fans, and I'm going,
Right.
there's got to be a better way. And now I've been in this so long that it's very much spite driven for me. I don't really care what avenue it is, independent software vendors.
As long as it works. Yeah.
As long as it just needs to work, and I need to be able to inspect it. And I think people are going to start demanding that. I think operationally, back to our original part of operational cops, OPEX, and being able to do more with less, more famously, that people are going to start demanding to be able to see something that's debuggable. And you're not going to ship the code base. You're not going to enable debug symbols. You're not going to expect your customers to be software engineers. So you're going to have to give them the tools to be able to debug what you're providing them, whatever that flavor is. If it's segment routing, if it's RSVP, if it's stuff like that. You can't, the days of just having nerd knobs and hoping it works, or believing the sales engineer when they put the nerd knobs up on the PowerPoint presentation, or working through, oh, you got the wrong combination of nerd knobs, sorry, you got to be on the TAC call, or the next build, release, something like that. Those days have to stop. Those days are coming to an end. It's not going to work. I think a lot of people have felt, you know, whether it's whatever, whether it's a story or not, you know, it feels like a lot of vendors, whomever they may be, have really pushed the Q&A onto the customer, whether it's to chase release notes, check marks, RFPs, I don't know, and I don't really care. The end result is even the big accounts, big and small, end up having to spend a lot of engineer time, which is already precious, kind of doing QA.
Kind of doing QA for the vendors, yeah. No.
You're spending money to. The whole point of a integrated system is something that's integrated. And especially if the argument is, well, we don't do special stuff, right? Well, then why doesn't it work?
Yeah.
If it's not special and you haven't changed anything for 5 or 10 years, or if you're following the industry, if you waited 4 years for VXLAN or whatever's supported on it, well, then why doesn't it work? Right? Well, okay, fine. Software engineering, nothing's perfect, nothing's visible. This is the argument I make in Beer 4. Well, what we do in networking is not some generic computing problem, right? It's not unbounded, right? We actually know what we're doing. We're reading a few bits at the beginning of something, however far we want to go, and then we have a bit of logic behind it. You know, we read a few things. How fast does it go by? When does it come? And we might change a few things.
That's it.
Where's it going? Right? We make a few decisions. We look up a few tables really, really, really fast. Right? That's where the magic of memory, space, time. It's all the same stuff. But if we represent that in code, you know, the ideas of formal methods, or not even verification, but validation, becomes so much easier. And now the relationship changes again. Now, if I can more easily validate the claims, I'm kind of holding my vendor more accountable, which ultimately is something that's going to happen. You know, I can't name names, but most people I hear from, they're kind of tired of their vendors for one reason or another. Wow, I got this licensing scheme.
Well, it's a pre-qualification. I mean, there's an old joke in software engineering when you're going through these various programs, that the way software engineers debug things is, the analogy is like you've got a car at the top of the hill and you're like, all right, let it go, smash it up. Wait, let's try it again. Bring it back up there. I didn't quite pay attention. Smash it up again. Smash it up again. And about the 6th or 12th time, your observations are, oh, okay, now I can fix this. Now I know what to do. You hope. But that's kind of what you're getting at, I think, is like the pre-validation. And part of this is kind of in defense of vendors, is that the software stacks that they're shipping are so complicated now and so intertwined with themselves that, you know, this is kind of back to, you know, the Arista point where they were, you know, they and other people were rapidly simplifying. And that's really what operators wanted. But
They wrote their own abstraction layer. I always thought
yes.
it was out of just sheer cleverness, but from what someone informed me is that they were originally going to use Fulcrum ASICs, and then Intel bought
Yep.
Fulcrum unbeknownst to them. It was kind of out from under them. And then they ended up with merchant silicon from Broadcom. And to me, the greatest decision they ever made was saying, we'll just bang the bits ourselves. We won't
Yeah.
use your SDK.
Leave it.
Just let us, And I think that worked very well to their advantage because they kind of became known for their code quality. Or they're just general QA. I know there was a lot more to it than just the software, and certainly a lot more to it than just the hardware abstraction layer. But I feel like having come up when they came up, that was a big differentiator in the user experience that they ended up delivering at that time. And I think that can be something that's attainable in the idea of disaggregated networking. I really would like people to be able to pick merchant silicon, pick an ODM that put it together with the right port configuration you like, or the right control plane CPU and memory that you need, and to have more than just one or two options, and the same ones at that. I won't name names because it's not about shaming here, but one of the shocking thing that leaves another bad taste in everybody's mouth, you go to disaggregated network, you go, okay, I want to get this switch. Now I want to install this software on it. Oh no, they didn't port it to this SKU. They didn't. But they support the same ASIC, Trident 3, this, that, Jericho 2. Yeah, but they didn't
Yeah,
port it
but
to
we
our. But we don't do it right. You could get another Jericho 2 with that software, but not our Jericho 2. Well,
Yeah.
what is this madness, right? There's no reason for that. And now especially, I don't necessarily think it's because of Tofino, but it probably helped a lot. Even these quote unquote fixed function ASICs, even what we would call merchant silicon, which is basically all that's going to come out next. I mean, Cisco has a great new one, the Silicon One. I forget the name of it. The one that's in their 8000 series routers is pretty incredible, at least on paper. I don't know anything else beyond that. But these merchant silicon chips, to have a generic interface to them, however good they're going to be. Again, I'm not out here saying we've solved all the problems and everything's going to be great, and let's just eat grapes and lay in the sun instead of operating networks. It's still software. There's still bugs. It's still going to be a problem. But if you kind of fix from the bottom, everything that bubbles up on top of it becomes more tractable, becomes more easier. Now I can implement a control plane or a routing daemon that doesn't have to mess with netlink and its weird semantics or something like that. I feel like 80% of beyond the software problem of porting stuff, 80% of the issue in disaggregated networking is everything's around netlink. For better or worse, this is kind of where everything has to go because, well, this is what we have in Linux, but this is the hardware abstraction layer, and now we need to sync it. Cumulus was very successful at this with switchd and being able to sync netlink to the hardware and vice versa, multi-billion-dollar company off of it, right? But we haven't progressed past that, really. I would like to say. Maybe I'm missing something. I don't know everything about everything, obviously, despite my passion for this part of our world. But we haven't gone much further than that. So I'm excited about P4. I'm excited about things like the switch abstraction interface, because the idea of I have this hardware, it has this certain chip in it. I would like to run these features with open source software, supported software, someone that will give me a support contract for this software, as opposed to my only option is the right soup from one of the 3, one of the 4, one of the 5 vendors that I've already dealt with, because it's right back to, well, now I got to kind of deal with their QA. Now at least, probably depending on my size, effectively one full-time employee is just going to be dealing with, whatever it is, right? With multiple vendors, hopefully not just one, right? Those days aren't going to scale. It's not going to scale with whatever people's cloud spend looks like tomorrow. I know everyone's talking about it. The tech thing's not going too great right now, but it doesn't matter what people's cloud spend are. In order to get those efficiencies, it has to change the way we've been doing this, and it starts from the bottom, in my opinion. It starts with what's actually moving stuff, because doing it in software, like we were discussing earlier, it only goes so far. You can't use NPUs. You have to do something that's pipelined and line rate. I mean, Netflix is doing 700 gigabits per second from one server. Are you kidding me? We can't. There's no FPGA. There's no NPU that's gonna help you out with that. If that's what some of these things are pushing. So yeah, I'm gonna need my 12 terabit spine or top of rack switch to maybe do a few things in that V pattern or in that traffic pattern that I wouldn't normally expect from that position in the network, from that device. Things like doing in-network machine learning, yeah, that's kind of wild. And I don't know a lot about those workloads. I'm service provider, but in high-performance computing and massive data link reservoir computing type folks, they're eating this stuff up, doing classification and neural networking type stuff in the switches. Utilizing that 12 terabits per second to actually compute on bits of data. Recirculating or orchestrating which data paths they go through. That's mind-blowing to me, but as a service provider who's doing some pretty simple stuff, this means I have a lot of power in my hands. Where's the tooling? What's that tooling going to look like? What kind of tooling do we need? How do we want to interact with that stuff? Because I want to give the same people that are interacting with CLIs, I want to give them the same experience, the same tooling to inspect those devices. I don't want to just give them a replication of, oh, now you get a Yang model. Now it looks like the Nokia, CLI, right? That doesn't really help me. It's just knobs, but now it's structured. I know it's an int or a float or a bool. I want to know what's behind the knobs, right? And I think we're coming to that, whether in some which way or fashion. So it would be nice to have more people in the space to be like, well, what could tooling look like if not Ansible, if not Terraform, if not another Python script that's scraping the CLI, right? What would it look like if we could actually get our hands dirty and wanted to build functions and build networks, not just from plugging and typing affectionately, for the different flavors that the vendors give us, but build it almost from first principles, given the tools.
You just signed yourself up to come back in a few months because there's a ton there to unpack.
Yeah. Sorry, I just blathered my mouth.
No, it's great, man. It's great. I mean, these are great points, and they're discussion points that need to be happening. So, in the meantime, where can folks find you, Aaron? And what's the Twitter handles and all that kind of stuff?
Yeah, for sure. Best place you can find me is on Twitter. The handle is Network Service, no space, full network service, full name. I'm hanging around Ripe. I don't think this will probably be released by the time Ripe's out, but yeah, you can find me on Twitter. Probably by the time this goes, you can play with P4, a simple environment. Just load it up in your browser. You don't have to do anything else. CSEE dot P4, the number 4, dot works, WORKS. It pops up a little container for you. Everything's built. And you can start doing the exercises that are brought from the network service group at ETH Zurich. Dr. Laurent van Bever and their group has put together a very interesting series of exercises based around P4 and P4 runtime in the control plane. The first one that I suggest people to start with is the layer 2 learning switch. It goes on to MPLS is the next one right after that. It goes all the way up to building your own layer 3 router. It's quite interesting. If you do it, you have questions, you want to talk P4 programmable data planes, I will talk your ear off. Find me on Twitter.
Awesome. And that wraps it up for today's show. We'll actually have this turned around before Ripe. So, yeah.
Oh, okay, cool. So if you're at Ripe, come find me. Yeah.
Yeah, awesome. All right, friends. Thanks for joining us today.
This was cool.
And
thank you so much. Thank you so much. Look forward to a couple months from now. I'll be saving it on my calendar.
Nice. All right, everybody. Peace and love out there. We'll see you next time.